Okay, question 3.10. Oh, I've lifted this straight from the textbook, but I've just changed the figures around. Okay, let me read out the question. A sample of a culture of bacteria is subjected to a 10-fold serial dilution. 0.100 milliliter aliquot. I had to Google what the hell an aliquot was because I didn't know. It just means a defined amount of liquid. Okay. Means repeated samples of the same volume. So 100 milliliter aliquots of the dilutions are grown on agar plates, and the number of colonies counted, assuming that one cell gives rise to a single colony, how many cells were there per milliliter of the original culture? Okay. Now, this can be quite important if you're an experimentalist and you're buying cultures of bacteria or whatever, and even though it's said on the tin what the concentration is, you might want to know that more accurately. So you would have to do this serial dilution, grow your cultures, and figure it out. Now, in this case, I actually can refer you to page 45 of the Maths from Scratch book. That will tell you exactly how to perform a serial dilution. And it will also say that in a case like this, you should start. So in order to calculate the original number of cells per milliliter in the original culture, start with the largest number of colonies that you can count the most accurately. Now, in this case, that is at the 10 to the minus 3 dilution. Okay, 238 colonies you count. So that's going to give you the most accurate answer. So, for example, you wouldn't use 10 to the 4 where you only counted 26. So, okay, let's do that. And now there's an equation that they use in the book. I just want to go through exactly what that means. So they give you this. N is equal to R times D over volume. Okay, now let's do a bit of digging here. N is the concentration of cells in original culture per milliliters. Okay, right. R is the number of cultures counted at a given serial dilution. So I've already told you we're going to use 10 to the minus 3. And that we know that one culture is equivalent to there being one cell. Okay. So R is essentially a count of the number of cells in that solution per milliliter, if that makes sense. And D, okay, now be careful with D because this is the relative dilution. So this is with respect to the original solution. And this is actually the inverse of the dilution we've stated. So what we're essentially saying is from the very start, we have diluted it 10 times 10 times 10. Okay, so the relative change in dilution is 1,000-fold. Okay, and that's a reciprocal of the dilution that we can measure the most accurately. Okay, and of course the volume is the volume of those aliquots, which was 0.100 milliliters. Okay, so let's plug all of this in. I hope that made sense. The number of cells per milliliter in my original culture is going to be equal to 238, which is the number of cultures I counted, assuming one cell per culture, multiplied by the reciprocal of the dilution at that of that plate, which is 1,000, 10 to the 3,
and I'm going to divide it by the volume, 0.100. Okay, that gives me a number of 2.38, that's 3 sig fig, times 10 to the 6 cells per milliliter. So there are 1 million cells per milliliter in my original culture solution. Okay, here we go.